So hi guys, let me know if I'm live. I'm waiting for your comments to understand whether I've come live. This is Dr. Patil, your faculty for medicine in PW MedEd, and today we are going to learn about how to deal with the ABG related problems in our NEET, PG, NExT or FMGE exams. Okay, now the level of questions keeps changing when it comes to the INICET or the probable proposed NExT exam. You're likely to expect a lengthy question with a lot of patient story, then ABG, and then asking you something related to it. And in the context of FMG or NEET PG, the question may be like flat and simple, giving you just one or two lines of patient story, one line of ABG, and then asking you to analyze it. Okay, so here is one problem. I hope you can see and let me know what is the ABG abnormality. There are two abnormalities here, two ABG reports here actually. So you should be able to tell me both of them. Okay. So first let me read through the problem here. What is the problem? Here we have a 28-year-old man with a known case of bronchiectasis. So he already has a respiratory disorder. He presented to the emergency room with 3 days history of increasing cough, sputum and dyspnea despite maximizing his bronchodilators. It's a case of bronchiectasis and recently there is worsening of symptoms. About a month ago, he had come to OPD and at that time an arterial blood gas analysis was done which showed the parameters in this range, right? What is the parameter showing? Parameter showed that pH was 7.38, pH was 7.38, PaCO2 was 65 and bicarb was 32. Okay, this is the ABG done 1 month ago. Now, ABG done at this point of time shows a pH of 7.28, PaCO2 of 70 and partial pressure of oxygen in the blood being 50 and bicarb is now 23. Okay. His vitals seem fair enough, right? Because he is having some degree of hypoxia, he is tachycardic, his respiratory rate may also be on the higher side. BP seems fair, so he is not destabilized as of now. Which of the following best characterizes current acid-base status? So the first question here is, describe the current acid-base status. Okay. Now, whenever we deal with an ABG problem, first question to ask is, right, when it comes to ABG analysis, the first question to ask ourselves is whether we have the acidosis or alkalosis. Acidosis or alkalosis. Now, how do we assess that? For that, we should know the normal pH. What is the normal pH? Normal pH is in the range of 7.35 to 7.45. That is the normal pH. Anything more than 7.45 would amount to alkalosis, and anything less than 7.35 would amount to acidosis. Okay, so if your pH is 7.45 plus, that would be alkalosis. If it is less than 7.35, that would be acidosis. That is the step number 1. So we are going back to this ABG. Let us concentrate on the current ABG. pH is 7.28. So what do we have here now? We have acidosis or alkalosis. Clear, right? It is less than 7.35. So in this ABG, what we have is acidosis. Acidosis. So even if you know this much, right, you will be able to rule out at least 2 options from the ABG questions. You will be left with most cases 2 options, and in that case you have 50% chance of getting the right answer even if you don't know anything more than this in the ABG. Clear? Okay. Now, once we have done whether it is acidosis or alkalosis, the step number 2 would be to see whether it is metabolic acidosis or respiratory acidosis, and vice versa. Like if it is alkalosis, that is your decision based on the pH, then you have to assess whether it is respiratory or metabolic, right? So for that, what we need to do is I give you a mnemonic. So the question number 2, first question is acidosis or alkalosis. The question number 2 that needs to be addressed is, the problem is whether it is metabolic or respiratory. Metabolic or respiratory. Now for this, right, there is a mnemonic. I call it as MS ortho. MS ortho, right? MS ortho is the mnemonic. You can also get other mnemonics, like you can also remember it as ROM or ROMS, right? Other mnemonics are ROM or ROMS. Okay, now I'll tell you what it stands for. Now in this case, right, to apply this mnemonic to decide whether it is metabolic or respiratory abnormality, I will be interested in mainly looking at 2 parameters. The parameters that I will be interested is partial pressure of carbon dioxide, PCO2 or PaCO2, and the second parameter I would be interested is the bicarbonate. sorry, the pH. pH and PaCO2 are the two parameters I would be interested in deciding whether the ABG abnormality is metabolic or respiratory. Okay. Now to apply the Rome as a mnemonic, it simply says respiratory opposite and metabolic equal, or if you are applying the ROMS as a mnemonic, it simply means respiratory opposite, metabolic same. Respiratory opposite, metabolic same. So what we need to do is look at the direction of the PaCO2 and pH, whether they are increasing or decreasing. So let us look at this ABG itself. In this ABG, right, what is the pH? pH is 7.28, that means it is decreasing. pH is lesser than 7.35, it is decreased. Right. And what is happening to the PaCO2? Normal PaCO2 is in the range of 35 to 45 millimeters of mercury. Right. This is something which is very easy to remember, because your pH range and PaCO2 range match the number, right? 7.35 to 7.45 is your pH range, and 35 to 45 millimeters of mercury is your PaCO2 range. Okay. So here PaCO2 is increased. PaCO2 is increased more than normal 45. So look at the direction of these arrows. Are they in the same direction or opposite direction? They are clearly in the opposite direction. So what happens if opposite, right? So we remember with this mnemonic, respiratory opposite, metabolic in the same direction, equal, or metabolic same, Rome or ROMS. Okay. Or you can follow my mnemonic, which is MS ortho, right? Here MS stands for metabolic, both in the same direction, right? pH and the PaCO2 in the same direction in case of metabolic, and ortho OR stands for opposite respiratory. That means pH and PaCO2 are in the opposite direction. MS ortho is the mnemonic to remember. Okay. So in this case, because they are in the opposite direction, respiratory opposite, ortho OR, opposite is respiratory. So this is a case of respiratory. So here we have acidosis, which is respiratory. So what we have here is a case of respiratory acidosis. Okay, clear? This much is clear. So now when I look at the options, there is only one option which actually holds good here, which is uncompensated respiratory acidosis. But now you may be confused कि ये compensation क्या है, right? We know now how to identify acidosis and alkalosis based on the pH. Then we also know how to categorize the abnormality as metabolic or respiratory with the mnemonic MS ortho, right? Looking at the direction of PaCO2 and pH, whether they are in the same direction or in the opposite direction. If both are decreasing or increasing, that means they are in the same direction. Then it has to be metabolic. MS here stands for metabolic, same direction. Opposite in case of respiratory. OR for ortho stands for opposite in the respiratory cases. So if they are in the different directions, like in this ABG, both are in the opposite direction, so it is a respiratory case, right? That is how we get to know the respiratory acidosis. Now comes the question, what is this game of compensation, right? We have this compensation. So third thing is to assess the compensation. Because kidneys and respiratory system are trying to keep your blood pH in the physiological range of 7.35 to 45. Okay. How do they do that? The lungs can play with your carbon dioxide. They can increase or decrease the carbon dioxide clearance to keep the pH in the desired range. And how kidneys can do? Kidneys can regulate the bicarbonate and they can regulate the proton elimination or H plus elimination. The main molecule which receives the H plus is ammonia. So it will decide how much H plus should be pumped out through ammonia and how much bicarbonate should be reabsorbed or lost in urine. So both of them, kidney and lungs, play together to help you keep your pH in the normal range. So if you have a metabolic abnormality, metabolic basically refers to dysfunction at the level of kidney, right? So if you have a metabolic abnormality, in that case your respiratory system will try to compensate and get the pH back to normalcy. And if you have a respiratory abnormality, your kidneys will try to compensate and get the pH back to normalcy. So there will be always a compensatory attempt from the opposite organ. Okay. So now we have to understand whether the compensation is appropriate or not. Why this is important? Because see, for example, if I am talking about respiratory acidosis, like in this case, the problem is from the lungs. That is why you have respiratory acidosis. Lungs are not able to clear carbon dioxide. There is retention and you have developed acidosis. Now the kidneys have to keep the pH back to the normal range. How can they do that? Kidneys can do that by increasing the base. Base here is bicarbonate. So kidneys can get the pH back to normalcy by elevating the bicarbonate. Okay. So the compensatory response from the kidney will be in the form of metabolic alkalosis. For respiratory acidosis, compensation will be in the form of metabolic alkalosis. Clear? But what if the patient also has, in addition to, see, you never know, there may be a respiratory acidosis plus one more metabolic acidosis in this patient. Like, see, this is a case of bronchiectasis. He has developed infection. He can go into sepsis. So if he goes into sepsis, he can develop lactic acidosis, which is a metabolic acidosis. So how do I get to know whether what I am seeing is purely respiratory acidosis or underlying this, right, disguised under this ABG, is there a metabolic acidosis, or is there a metabolic alkalosis also which is buried by this respiratory acidosis? How to unearth a underlying additional ABG abnormality? That we can understand when we look at the compensation. So we have to calculate the appropriateness of compensation, whether the compensation is appropriate for this level of abnormality or it is inappropriate. If it is appropriate, then that means you have only one ABG abnormality. But if it is inappropriate, that means you have an additional ABG abnormality, right? So how to calculate that? There is a simple table here which helps you to calculate the appropriate compensation. So for example, if you are dealing with a case of metabolic acidosis. Metabolic acidosis means what is happening there? pH is less than normal, pH is decreased, bicarbonate would be decreased in a case of metabolic acidosis, and carbon dioxide, because your bicarbonate is decreased in a metabolic acidosis, base is decreased, the carbon dioxide should also be decreased to keep the pH in the normal range. So we can calculate the expected PaCO2, right? We will get to know how much is the expected PaCO2. If the patient's PaCO2 is in that range, then what you have is a single ABG abnormality. But if it is outside that range, more than that or less than that, that means there is an additional ABG abnormality. Similarly, we have formulas for metabolic alkalosis, respiratory acidosis and respiratory alkalosis. What I am dealing here is a case of respiratory acidosis. So let us apply this formula for that case. Respiratory acidosis. Okay. What is the formula? Respiratory acidosis means PaCO2 is increased. Now to compensate for that, see, PaCO2 is adding acid. Carbon dioxide dissolves in water, becomes carbonic acid. So that is why you have acidosis. Now to compensate for that, you need to increase the base. So kidneys will increase the bicarbonate. So bicarbonate is expected to be elevated. So whether the bicarbonate elevation is appropriate or not, we need to see. So for that we have formulas to calculate delta bicarbonate. What is delta bicarbonate? Delta bicarbonate is the expected rise in the bicarbonate. Delta means change, expected rise in the bicarbonate. We have two formulas here for acute and chronic. So if the respiratory condition is acute, expected rise in the bicarbonate will be 0.3 into change in the PaCO2 if it is chronic, and if it is acute, 0.1 into change in PaCO2. Okay. So going back to this question, the story of this patient is long-standing, right? It's a long-standing case of bronchiectasis, and previously also when we look at his ABG, his PaCO2 was elevated. So I can conclude that this is a case of chronic respiratory acidosis. It has worsened recently, but it is the patient is a known case of chronic respiratory acidosis. So we are dealing with chronic respiratory acidosis here based on the history. Now I have to calculate the appropriate elevation in bicarbonate, and for that, what is the formula? For the appropriate elevation in a case of chronic, 0.3 into delta PaCO2, right? So let us apply that formula here for this ABG. 0.3 into, see, we are calculating the delta bicarb, means rise in bicarb, expected rise in bicarb is equal to 0.3 into delta PaCO2, right? So 0.3 into, what is delta PaCO2? Delta basically means difference. So we are looking at the normal PaCO2 and the current value. How much is the difference? So we are defining normal as the upper limit cutoff as 45, right? 45. And how much is it now? 70. So how much is it over and above the normal cutoff? 45 to 70. How much is it? 25. Yeah, 25. So delta PaCO2 here is 25. So in this case, the delta PaCO2 is 25. So 0.3 into 25, how much is it? 0.3 into 10 is 0.3 into 10 is 3 and 1.5, so around 4.5. Not 4.5, let me correct my mathematics. So 0.3 into 10 is 3, 0.3 into another 10 is 3, so 6 plus 1.5, so 7.5, right? So your bicarbonate is expected to rise by around 7.5, right? Around 7.5. So delta bicarbonate here is around 7.5 according to the formula that I just described. Because we are applying this formula because it's a case of chronic respiratory acidosis. If it is an acute case, then I would have applied this formula 0.1 into delta PCO2. Okay. So we have calculated the expected bicarbonate. This is delta bicarbonate. That means not the expected range. This much bicarbonate should get elevated over and above the normal range. Okay. So what is the normal range of bicarbonate? It is up to 26 millimoles per liter. So it should be above that. So 26 plus 7.5. How much will that become? 26 plus 7.5 would be 30 plus 3.5. Around 33.5. So expected bicarb in this case would be around 33.5. But how much do I see here? 23, right? So remember this point now. Expected HCO3 in this case is 26 plus 7.5, that would be 33.5. And what do I see here? Only 23. So what does that mean? Is it as much as it should be, or it is less than what it should be, right? It should have been around 33.5, but it is way lesser than that. Clear? So when it is lesser than that, that means there is an additional ABG abnormality. So what we are dealing here is not just a pure case of respiratory acidosis with the metabolic compensation. What we are seeing here is an additional ABG abnormality. So one thing is respiratory acidosis is there. What is the additional ABG abnormality? That is what we need to decide here. Now what is happening to the bicarb here? The calculated or expected bicarb is this much, right? Actual bicarb here is 23. Actual HCO3 minus is 23. So that means the bicarb is lesser than expected. So when bicarb is lesser than expected, what do you see? It is a metabolic acidosis. So this ABG has, in addition to respiratory acidosis, there is an underlying metabolic acidosis, right? There is an underlying metabolic acidosis. So possible because this patient has infection and he may be going through sepsis, and that can cause metabolic acidosis. So this is a typical case of the chronic respiratory acidosis with an additional metabolic acidosis, and there is no appropriate compensation happening here, right? So this is how we can identify another ABG abnormality lurking under the disguise in one of the ABG issues, right? So here the diagnosis or answer would be obviously uncompensated respiratory acidosis, okay, because the question was very simple. But if I give you the option where saying this is a pure case of respiratory acidosis, or if it is a respiratory acidosis with appropriate metabolic compensation or appropriate metabolic compensatory alkalosis, another option is respiratory acidosis with metabolic acidosis, right? What should be your answer? It is respiratory acidosis with metabolic acidosis. Okay, so that is one ABG. Now let us look at one more ABG, like the previous ABG. The patient had got one ABG done 1 month before the current visit, right? So let us look at this ABG. Let me write it down somewhere. Okay, so this is for the current ABG. This calculation was for current ABG. Now let us do that for the previous ABG also. Okay, so when we look at the previous ABG, what were the findings we had? The previous ABG, the pH was 7.38. pH was 7.38. What was the PaCO2? 65 and bicarb 32, right? PaCO2 65 and bicarb 32. So let us follow the same three principles that we have learned so far. Okay. First thing is acidosis or alkalosis. That is where the problem is going to come now, right? Is it acidosis or alkalosis? Can anybody comment and tell me what do we have here? What is the normal range of pH? 7.35 to 7.45. Okay, but the pH here is normal. Then you may say, sir, there is no acid base disorder because the pH is in the normal range. But what is happening to PaCO2? What is the normal PaCO2 range? Let me write the normal ranges for us to clearly understand. The normal ranges for pH is 7.35 to 7.45. PaCO2 is 35 to 45 millimeters of mercury, and bicarb is 22 to 26 millimoles per liter. Okay, so here I can clearly see what is happening with bicarb. Bicarb is increased, PaCO2 is increased, but pH is in the normal range. So can I call that this is normal ABG and there is no abnormality at all? Obviously no, because I can clearly see that the contents of the ABG are abnormal. The only thing is pH is in the normal range. Why? Because here there is compensatory mechanism which is putting the ABG abnormality or the pH back to normalcy. Okay, so there is a ABG abnormality, but compensatory mechanism has been able enough to get the pH back to normal range. That is why it is in the normal range. Now the question is how to identify कि मेरे पास acidosis है या alkalosis है, right? So for that, remember we use 7.4 as the cutoff. 7.4 as the cutoff. So if you see any ABG where the pH is in the normal range but its contents are abnormal, it is still an abnormal ABG. And to decide whether to call it as acidosis or alkalosis, use 7.4 as the cutoff. Less than 7.4, it is still acidosis but with appropriate compensation, and more than 7.4, call it as alkalosis. So this is an abnormal ABG, and pH being less than 7.4, it is acidosis, right? So first question addressed. First question, acidosis or alkalosis? This is acidosis because the pH is less than 7.4. Now if I tell you that PCO2 was 40 and bicarb was 23, then it is a normal ABG, right? pH 7.38, PCO2 40, bicarb 23, everything is in the normal range, then it is normal ABG. यहाँ पे pH normal range में था but PaCO2 and bicarb were in abnormal range, तो यहाँ पे एक ABG abnormality है, and to understand कि acidosis है या alkalosis है, we will use 7.4 as a cutoff. जब हमने ये अप्लाई किया तो pH is less than 7.4, so it is acidosis. अब आगे डिसाइड करना है कि मेटाबॉलिक है या रेस्पिरेटरी है, दैट इज द सेकंड स्टेप. सो फॉर दैट व्हाट वी सी इज द डायरेक्शन ऑफ द pH एंड PaCO2. तो यहाँ पे pH इज लेस देन 7.4 मीन्स कि डिक्रीज हो रहा है, राइट? और जो PaCO2 है वो इंक्रीज हुआ है, सो दे आर इन द अपोजिट डायरेक्शन. सो व्हेन दे आर इन द अपोजिट डायरेक्शन इट इज रेस्पिरेटरी, राइट? मेटाबॉलिक सेम, अपोजिट रेस्पिरेटरी, MS ortho. So what we have here is respiratory acidosis. Now the question is, if it is respiratory acidosis, how do you explain the normal pH? The pH is normal because of the kidneys compensation. So kidneys are compensating by increasing the bicarb. See what happened basically, PaCO2 increased, your lungs were not able to clear the carbon dioxide. This carbon dioxide will dissolve in the water to form carbonic acid. That is why the blood is becoming acidotic. To tackle the acidosis, you need to add more base. So kidneys will add more bicarbonate into the blood. And when kidneys add more bicarbonate into the blood, bicarbonate level will elevate. So this is kidneys attempt to get the pH back to normalcy. So if it is successful in getting it done, then we call it as fully compensated ABG abnormality, right? So in this case, if the pH is in the normal range, that is where we call it as fully compensated. Attempt तो हमेशा होगा, right? Every time PaCO2 goes high, kidneys will try to raise the bicarb. But if this change is good enough to get the pH back to normal range, means within this range, then it is called as fully compensated. So यहाँ पे pH is definitely in the normal range, so this will be called as fully compensated. Fully compensated. So the original, the 1 month old ABG that this patient had presented had respiratory acidosis that was fully compensated. Now what he has is uncompensated respiratory acidosis with an underlying metabolic acidosis also, right? With an underlying metabolic acidosis also. Okay, that is clear. Now this is how we approach, right? So now the next step is to see whether the compensation is appropriate. You might say, sir, pH तो normal है, फिर क्यों हम compensation की appropriateness के बारे में बात करेंगे? That is important because you never know, there may be an underlying other acid base disorder lurking which you may be able to not pick up from this simple analysis of ABG, right? Okay, now what is the expected compensation? Expected compensation is rise in the bicarbonate because the PaCO2 is rising. So we can calculate the delta bicarb. Okay, because it is a case of chronic respiratory acidosis, we are applying the formula 0.3 into delta PaCO2, right? So 0.3. So third step is calculation of expected compensation. The primary problem is rise in PaCO2, that is the primary problem. So the compensation will be in the form of rise in bicarbonate. Okay, so always remember this, bicarbonate and PaCO2 when they are trying to compensate for each other, they follow the same direction. अगर PaCO2 increase हो रहा है तो bicarb has to increase to compensate. अगर PaCO2 decrease हो रहा है तो bicarbonate has to decrease to compensate, and vice versa is true. If bicarbonate is increasing, PaCO2 should increase to compensate, bicarbonate decreasing, PaCO2 should decrease to compensate. Okay, so अगर हम formula apply करेंगे तो 0.3 into delta PaCO2 is the difference between normal PaCO2 and the patient's current PaCO2. So the current PaCO2 in the original 1 month old ABG is 65, normal upper cutoff is 45. 45 to 65 is 20. So delta PaCO2 is 20. Delta PaCO2 here is 20. So 0.3 into 20 is 6, right? So the change expected in bicarb is 6. So the normal bicarb upper cutoff is 26, that I have already mentioned here. 26 plus 6, that is the expected bicarb. So delta bicarb is this. So expected bicarb would be, expected HCO3 minus would be 26, which is the upper limit of bicarb, plus delta HCO3 minus, that would be 26 plus 6 equal to 32. So the expected bicarbonate for this patient's 1 month old ABG is 32. Now how much we see here? 32. So whatever we had first time 1 month back when he presented was a very typical respiratory acidosis that was fully compensated, and there was only one ABG abnormality because the expected compensation is what we are seeing here. The bicarbonate is as much as expected. If it was less than expected or more than expected, that is where I would have thought of an additional ABG abnormality. So originally सिर्फ एक ही ABG abnormality था. Now that he has developed an infection that would have caused the metabolic acidosis, that is why current ABG shows respiratory acidosis with metabolic acidosis. Clear? So you got the approach. So this is how we approach a case of ABG. So first thing is three standard steps. First thing is answer whether it is acidosis or alkalosis, looking at the pH. Second thing is to decide whether it is metabolic or respiratory. So for that, look at the direction of the pH and PaCO2, and after that, not to miss another additional ABG abnormality, you have to calculate the expected compensation. So here is a small table for you to memorize. Remember, most important point you need to memorize is the appropriateness of compensation for the metabolic acidosis, right? So in case of metabolic acidosis, there is a formula which is also called as Winter's formula. Winter's formula, which is for calculation of expected PaCO2. See what is happening in metabolic acidosis, bicarb is decreased. So now you expect the PaCO2 also to decrease. So whether the PaCO2 is as much decreased as expected for this level of pH, or whether it is decreased more or less, right? So we apply the Winter formula, which gives me directly the expected PaCO2. The formula is 1.5, right, into serum bicarbonate plus 8. 1.5 into serum bicarbonate plus 8 plus or minus 2. That gives you a range of expected PaCO2. If the patient PaCO2 is more than this or less than this, there is an additional ABG abnormality, right? So let us follow through some like telegram questions on the ABG abnormalities, so that by the end of another 1 week we would have addressed all types of ABG abnormality with different permutations and combinations. So today was basically initiation. I hope you have understood the initial approach, right? So now practice solving the ABG questions following these 3 steps: acidosis or alkalosis using the pH, then metabolic or respiratory using the mnemonic MS ortho, and after that calculate the appropriate compensation is there or inappropriate compensation is there. Okay, that's it for today. Now what I will do in the second session of the ABG abnormalities, we will particularly take up the metabolic acidosis. So when we deal with metabolic acidosis, there are some additional steps. We need to calculate the anion gap. That will help us to identify whether, that will basically help us to identify the underlying cause for metabolic acidosis. And the second thing is also something called as delta gap, which will be only calculated if you have a high anion gap metabolic acidosis, where we will try to see if it is just simple high anion gap metabolic acidosis or there is additional normal anion gap metabolic acidosis also involved in a particular patient's pathology. Now to do that, we need one more session, so I'll be doing one more follow-up session where we will be concentrating more on the metabolic acidosis. So for now, what is my recommendation? Solve as many questions as possible using the first 3 principles that you learned, and by the time we connect again in the next session, please memorize this table. Okay, you might ask me, sir, do I need to really memorize? My recommendation is yes, because of late we have started seeing questions directly about the compensation or questions asking you whether there is a single ABG abnormality or multiple, and until and unless you can calculate the expected compensation, you will not be able to answer these kind of questions. Okay, so memorize this table, and if you ask me to, sir, pick only one formula that I need to remember, then you have to remember Winter's formula. Maximum questions are going to come from that. Okay, the second important will be the respiratory acidosis. There are 2 acute and chronic, both you need to remember. Anyway, formulas are easy to remember, so I hope that it helps you. So I will see you in the next session. Let us continue our journey of ABG. So right now, that's it from me, guys. Thank you.